Hello, let's continue our Sudoku adventure with Index Finger Arrows by PjoeterBliep. This is a tribute to Index Finger puzzle by Marty Sears. It's quite the puzzle. We got some index fingers in here, and they do index. All right, let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now, these index fingers are both arrows and index fingers, so they have to fulfill both rules, but we're doing them separately because they're kind of two separate constraints that have been combined into one. So, first of all, they are arrow constraints, and so there's a circle in the grid with an index finger attached to it. So whatever digit goes in the circle, say this was a 5, the two digits on the index finger must, or not the, yeah, I guess it is always two digits, but the digits on the index finger must sum to that circle value. So it could be, say, 2, 3, like that. So this would be one way to fulfill the arrow constraint. We had a 6 here, we could do 2, 4. Now, they're also index fingers. So when an index finger reads A, B, C with A on the circle, B on the middle of the finger, and C on the fingernail, the digit A, so this is A, must appear in row B, column C. So let's go to row B. Row B is this one here. This is row 1, row 2, row 3, row 4. This is row 4. Column 2, this is column 1, column 2. So this is row 4, column 2. And this is the digit we put in there, a 6. So that's how we would fulfill the index finger. And that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how do we want to get started? Of course, it's always the question. Every single one of these circles, yep. So we can't repeat digits on any of these fingers because they're either in the same row, same column, same box. Just happens to be. We don't have a finger that goes like this, for example. So we're not repeating digits on them. So the minimum I could put on an index finger is 1, 2, and that adds to 3. Now, that's kind of interesting because most of these are not going to be 3 because the 3 is going to force 1, 2. And so we're down to this square. This square is where 1 and 2 are. And so we'd be pointing at one of these 4 squares and we'd be placing digits there. So it feels like we can't do too many of those 3s, but we'll see. We also know there's never a 6 on an index finger, right? If you try to put a 6 here, what are you going to put here to add to what? So row 6 and column 6 are never going to get indexed. I don't know what to do with that either. All right. So what else can we do? We might be able to combine some arrows. Yeah. So combining sums is a very powerful thing that you can do in Sudoku variants that involve sums. So always be looking for it. So I'm going to talk about these green cells. These are on a finger. These are on a finger. And so the sum of this is this digit, and the sum of this is this digit. So I can say that the sum of all 4 greens is equal to the sum of the 2 purples. Now the 4 greens at minimum are 1, 2, 3, 4. That adds to 10, which means that at minimum purple also adds to 10. So we cannot use the 3 because 3 would have to go with 7. So we can do 4, 6. We can be a 4, 6 pair, or we can be both 5. Both 5 seems completely viable. All right. So these 2 add to 10. That's what I got out of that. Can we combine anything else? I don't know if it makes sense to include this as well. Probably not. Okay, I do have one little piece of logic here. I don't know how useful it is, but let's call these the green cells and these the purple cells. Now we know at least one green cell is equal to the purple cell, right? We're roping, right? These 3 digits are the same as these 3 digits in some order because they can't go here, so they have to go down here. So that's our 6x6 roping. So one of these green digits goes up here on this finger, but we know that they're not both exactly the same because that would make both of these sums the same, and that would be repeated in the box. And so that means there is one of these digits on this finger ends up on this finger over here, exactly right there. And then one of our purples is the other green. So we're gonna have like green, purple here. So the 2 greens plus this purple. Why don't I just give a unique color? Unique color doesn't really help too much, does it? So here's what it would look like if I gave a unique color to all 3 of these: green, purple, orange. We know green, purple, orange go up here. This is gonna not be the orange because if this was orange, this would also be green, purple, and they'd have the same sum. So this is not orange, meaning it's green or purple. And that means that this has the other green, purple plus an orange. So I don't even know if that doesn't seem that much more clear. Maybe less clear. Anyway, that's kind of the point. But I don't know what to do with that, to be honest. I was kind of hoping it would go somewhere. There's gotta be something with indexing that's interesting, right? Is there something wrong with with adding to 4? So like if this was a 4 and this was a 1-3 pair, then we'd either be in row 1, column 3, or it'd be in row 3, column 1, and we'd be placing a 4. Seems okay. Well, it wouldn't be here. Okay, so I guess one thing we can say is that this digit doesn't repeat in its box. So if we were to include a 1, if this were, let's see, it's B is the row. So this digit here, if it were a 1, we can't repeat this anywhere up here. So this would have to be a 4, 5, or 6. It would have to be 4 or 5, making this 5 or 6. If there's a 1 on here. Now, if the 1 were here, that means column 1. This just couldn't be a 2, but already can't be a 2. So I don't know what to do with that information. Just a thought. Same thing over here. Similar over here. Row 1. Row 1 is a bit of a problem for this, because that would mean this digit would wouldn't end up here. It would end up one of these two. It would end up on this guy. Oh, yeah, hold on. So this can't be a 1, right? Because if this was a 1, it's telling us that this repeats in its row. So in general, these guys can't match the row they're in. The B digit can't match the row it's in. So if I were to put 1 through 6 on here, they're never 6. This is never 1. Sorry, it can't match the row that its circle is in, not itself. So this can't be 1, and this can't be 1. This can't be a 2. This can't be the row. This can't be 5. And this can't be 3. Okay. And so now the fingernail, C, can't match its column, the column of the circle. They're never 6. This can't match column 2. This can't match column 4. This can't match column 6, so that's fine. This can't match column 2. And this can't match column 1. Did I learn anything interesting there? I'd have to look. Let's see. And then there's also there's some conditionals here. Like if this was 1, then we're in row 1, so this wouldn't be able to be 1 or 3. Wait, so can we add to... I don't think we can add to 4. Well, no, this could be 1. No, it would... That would tell us we're in column 1. Okay, and then it would go down here. Shoot. So I could do 1, 3 here and add to 4. Can I add to 5? I could do 1, 4 here and add to 5. Adding to 6, I could do 1, 5. Or, see, I don't have a 2. So do I always need a 1? Yeah, of course. So obviously I always need a 1 here. Because without a 1, my minimum sum is 3, 4, which is 7. Okay. Yeah. So I guess you always need a 1 or a 2 on these fingers. There's always a 1 or a 2 present, because without that, 3 plus 4 is 7. Because we can't repeat digits. Okay, that's an interesting information. So the 1 in one of these two does take 1 out of these, and that means this has to be a 1 or a 2 in order to be small enough, and we must have a 2 in one of these. Okay, that's interesting. I don't know that I realized that before. I wonder if there's something special going on. I don't think so. Anyway, so we need a... So that means that all of our indexing is going to be in this area here. These are the only cells that can be indexed. It's interesting. Let's look at this a little more carefully in a minute, but 2 isn't one of these. That means 2 is down here somewhere. Anything special about 1s, or should I look at this? Or so this has a 2 on it, so it can't have a 5 on it for sure. So let's look at some options for the 2 here, maybe, because this got limited. So we're either in row 2 or column 2. We're placing a 4, 5, or 6. Now this can't be placed over here, so we can't be in row 2, columns 4, 5, or 6. But that's fine. We're not going to be there. We're never going to be a 2 with a 5, 6. So these are out. So this is where this can end up. So it can't end up here. Right. So 2, and it can't end up here because we can't do 2, 1 here. So we're either 2, 2. Oh yeah, this, we don't have a 1, so we're not there either. So we're either row 2, columns 2. Sorry, this is row 2, columns 2 or 3. Or we're row 3, columns 2 or 3. Wait. No, or we're row 3, column 2, exactly here, as a 5. I'm trying to work through how this works. Sorry. There's a lot of case checking here, but there's probably a cleaner way to think about it, but I need to figure it out. Or we're in row 4, column 2 here. We'd be a 6. So here we'd be a 4. Here we'd be a 5. Here would be a 5. Here would be a 6. So yeah, like the further down we get, the bigger we are. So 4 would put 4 here. 5 would put 5 in one of these 2. And 6 would put a 6 here. I don't know what to do with that information. All right, so maybe that's not the next thing to look at. This definitely has a 1 on it, so we're either here or here. We never put a 6 in, so we're never there. And we don't have a 2, so we're never there. Not row 2, not column 2. This is limited. This is a 2, 3, or 4. What would that mean? So that would be a row 1, so a 1 here. Column 3, we put a 3 here. This would be a 4, and that would be a 4. This would be a 2, and that would be a 6. That actually works, unfortunately. Does it have to do with one of these 2 being this digit? I don't know. Okay, so I guess one thing I didn't notice is that because these 3 end up here, none of these are 6. None of these are 6. So 6 is one of these 3. I really don't think that's super helpful. Actually, that means 6 can only be here. Oh, this is the only place for 6 in the box. Okay, that would have been really nice to notice. So if that's 6, this is a 1, 5 pair. And so we're either going to be putting a 6 in row 1, column 5, or in row 5, column 1. A 6 ends up in one of these 2. Okay. This isn't a 5. Oh, it was never going to be oh, no, we just removed 6 from here. That's fine. So 1, 5 pair, 2, 3, 4. So this 1 or 5 ends up on this. All right. So I'm gonna, I don't know exactly how to do this, but I'm just gonna pick a different color for each of these. And this 6, I just want to keep track, ends up either here or here. Since it's limited to 2 places. What else can I do here? I'm like 13 minutes in and I have nothing. So the 1, 5 pair takes 5 out of here. Can this be, okay, so can we place a 3 in any of these? The only way we're placing a 3, the only way any of these sum to 3 is if it's row 1, column 2. So if it's 1 in the knuckle and 2 in the fingernail, that's the only way we get a 3. So 1 in the knuckle, and this knuckle can't be 1. Why not? Right, because it can't match this guy. So this guy's never 3. Because the only way we would be placing a 3 is 1 in the knuckle and 2 in the fingernail to put it here, but we can't put it here for this guy because this would be 3 and that would be 3. So I guess this isn't 3. If this was 1, this would be 1, and this would be 6. That does a lot. This can't be 4 anymore because it can't be 1, 3. So I wonder, what do we do with that? It makes a whole lot more sense for this to be 5 versus 1. This was 1. This would be 1. The only way this is 4 is if this is 1, 3. So this would be 1, 3. Can we place a 4 there? In row 3, column 1. This would be a 4. Shoot, that works. Where are all the 1, 3? I guess 4 can... one of these would have to be a 4 in order to be able to do 1 plus 3 is 4, ever. I mean, that seems reasonable so far. I'm just going to write 3, 4... 2, 3, 4, 6 in here to remember the 1, 5 pair. Shoot, what else are we doing here? So if this was 1, 2. Oh, okay. Something I didn't notice about this. Remember, if this is a 3, the only way that's working is we put a 3 here, because the 3 would need to be in one of these 4 cells. Sorry, it would actually only one of these 2 cells, row 1, column 2, or row 2, column 1. I don't know why I thought it was these 4s. I was thinking 1, 2 pair could be 1, 1, or 2, 2 for some reason. It certainly doesn't have to 3. So 3 would have to be one of these 2, but actually this can't be 3 anymore. So the 3 would be here. So the only way we're doing 3 is knuckle 1, fingernail 2. But if this is knuckle 1, fingernail 2, the fingernail 2 places this as a 2, which means it can't be 3 by Sudoku, because of the corner mark 2's here. So therefore, this isn't a 3. For what it's worth, it places a 4 or a 6. 4 is either here or here. Now 6 has a few options. It could be 2 plus 4. Okay, we are not doing 2, 4 to add to 6. How about 4, 2? That can't add to 6. The 6 sees them. So the only way we're adding to 6 is 1, 5, which we actually do at some point, and that's here or here. So 6 can only be in one of these 2. 6 must be in one of these 2. What am I saying? This isn't 6. I don't know. I don't know what I'm saying. If this ends up 6, this is 6. What I'm trying to figure out is if 4 is viable in any of these sums. And the way 4 becomes viable is either here or here, placing a 4 in one of these 2. Which would make that 6. If that was 4, that would make that 6. I don't know. Is it this guy? This guy's pretty limited. So the kind of area that we occupy is 1, 3, 1, 4. This would be as 4 or 5. There must be some way to think about this, but anyway. Or 2. It's this square here. And this would be 4 and 5. Wait, so 4, 5, 5, 6. Oh no, we're not here. We don't add to 6. So this digit ends up in one of these 3. Oh, it can't be 3. I can get rid of 3. So it's either 4 here or 5 in one of these 2. Oh, and this can't be a 5. Oh, this can't go on its own digit. So 1, 3 is not viable. Sorry, 2, 3. 2, 3 is not viable. Can't do 2, 3. Can't do 2, 3. So if it's 2, it's 2. Oh, we can't do 2, 4 because I can't add to 6. So this isn't a 2. This is a 1. Okay. So we're either a 4 here or a 5 here. Four's on one of these two. Yikes. That's not 4. All right. I feel like we need to think about, we can't place ourselves on our own finger. Can't place a circle on its own finger. Because that's kind of what happened here. Does this 1 help at all? 1, 5 pair looks down, 1 looks down, 1's one of these two. This goes here, or it goes here as a 4 or a 5. It's got to do something, right? This is 1 less than it. So this is 5 or 6. If this gets placed, so if this was a 3, we'd end up with 2, 4, 6. That works. If this was a 4, we'd end up with 2, 3 pair with a 5, and that works. Okay, maybe I can think about where this guy ends up. So it's either going to be row 2, column 3. That's not going to happen. So this can't be 2, 3. So this is not a 2, right? If this was a 2, oh, and that places the 2. Okay. If this was a 2, this is a 3. So that tells us in row 2, column 3, we're placing a 5 or a 6, but we're not. So since this isn't 2, that places the 2 here. Okay. That's not a 2. This is a 3, 4 pair, so that's not a 3. In fact, this is just 2, 5, 6. All right. Progress, perhaps? Oh, interesting. 3 places a 4 here and a 4 here, and that matches up. 4 places a 3 here and a 5 here, and that matches up. Okay, so this is just going to resolve by Sudoku. We can't do more logic with it. What else can we do then? This isn't 1, 2, or 6, so it's 3, 4, or 5. This is this guy now? Like, where can this actually end up? It's restricted. Where can it end up? Can it have a 2 on it? So can it be row 2, I guess is a question. So in row 2, where can this end up? Certainly not in these. So if this were a 2, this would have to be a 1, 2, or 3. Okay. I'm not really seeing the problem. The only way it's 6. Okay. The only way it's 6 is if it ends up in. Okay, so how could this be 6? That's the question I think we need to ask. At least for now. If this was 6, then we gotta index a 6 somewhere. And we already know 2, 4 doesn't work, so we gotta index one of these 6s. We're certainly not indexing the 6 here if this is a 6. So we'd have to index this one. So we'd have to be 5, 1. 5 here, 1 here. And that doesn't work because that breaks this 1, 5. Since this is 1 or 5 only, this can't be 1, 5. So this doesn't add to 6 because we can't do 2, 4 or 1, 5. Okay, that's the simpler option. So we know that 2, 4 doesn't work, so we can't place a 6 here or here. There just aren't 6s there. They see this 6. So 1, 5 is the only option, but if we were on 5, we'd break this. So there we go. So this doesn't have 5 on it. If this had the 2 on it, it doesn't have this 3, 4 on it. It would have the 1 on it. Oh. Remember this logic where these aren't the same as each other, but they share 1 digit. So if they shared the 2, so we know there's a 2 on here now. If they shared the 2, they couldn't share this 3, 4. Therefore, they share this 1, 5. But we can't be 3 and we can't be 7. Therefore, there is not a 2 on here. Therefore, there's a 1 on here. So that's 1 and that's 2. And therefore, this is 1, this is 5. Okay. So now we know where this 6 goes. It goes in row 5, column 1. So that makes this a 6. Wow. Okay. Progress. 2, 5 pair. That's not a 2. This is 1, 3, 4. All right. This isn't 2 or 5. That's a 6. There we go. I don't need these grays anymore because we got our 6 placed. Where does this 5, 6 end up? It ends up in one of these two. No, it's... Hold on. Oh, yeah. Column 2. 3, 4. Oh, okay. This goes in one of these two. It can't be 6 then. We place this 6. Oh, no. Yeah, row 3 or 4, column 2. So this ends up in one of these two. It can't be 6. So it must be 5, which makes this 3, which makes this 4, which makes this 5. All right. And does that work? Row 3, column 2. Perfect. This is now 3 and 4, and that's 6. So in row 3, column 1, we have a 4. So that's 4. That's 3 and that's 2. That's 3. These are not 3s. Now this is 6. Remember, it has to be 1, 5. So that's 1, that's 5. That's 4, that's 2. And so row 1, column 5 is a 6. In fact, we ended up with a 6 in both of the 1, 5 options. Okay. Now I think it's just Sudoku. All the fingers are done, right? Did we place this one? Did we place the 5? Yeah, that 5 goes there. All right, let's just see if it solves, if the Sudoku solves. This is 2, 3, 6. So that's our 2. This is 1, 4, 5. So that's 4. This is 1, 2, 3. Oops, 1, 2, 3. So that's 1, 3, and 2, 5 and 1, 6 and 3. And then down here we need the 4, 5, and 6. So 4, 5, 6. There we go. Wow, that took a long time. It didn't feel that long, actually. But yeah, I don't know where my stumbling block was. There was just a lot to kind of discover about how this worked. Probably if like I was used to the constraint, I would have more tools to think about it. We had to build them up solving. All right, well, very interesting puzzle, PjoeterBliep. Hope you enjoyed this. If you did, then why don't leave a like, subscribe, and a kind comment below.